All right, welcome back to Mr. PL's with Algebra. This is Unit 4, Topic 2, Lesson number 7. Today's, we're going to focus on changing standard form into factored form, but when there's a leading coefficient. When that leading coefficient isn't 1 like it was in the last video, which I ran out of time on. All right, so this is first let's start by practicing what we learned in the last video, which was figuring out, well, okay, how do we change standard form to factored form? By factoring it. Ask ourselves, what two numbers have a product of C but add up to B? So 4 times 4, so we know it's a positive C, which that means it has to be either both positive terms or both negatives, because that's the only way you're going to get a positive product. So it's going to be x minus 4 times x minus 4. Multiply negative 4 times negative 4 is 16, and add them, you do get negative 8, so it does work. Or x minus 4 squared. All right, so negative 12. So this time, since we have a negative C, that means we have to have one positive and one negative factor. And then we know that the B term is positive 1, so that means the positive 1 has to be 1 bigger than the negative 1. And so it's going to be 4 and 3. So then the 4 has to be the positive because B term was also positive, x minus 3. Add the two numbers, you do get positive 1, and multiply them, you do get negative 12. All right, so once again, the C is negative. So that tells us that it's going to be 1 positive, 1 negative again. The B term is also negative. So that tells us that the negative 1 has to be the bigger number by 3. So it looks like it's going to be 7 and 4. X minus 7 and x plus 4. Because negative 7 is 3 bigger than 4, and multiply them, you do get negative 28. All right, so the C term is positive, so that means they either have to both be positive or both be negative, both factors. I believe that's going to be x plus 6 times x plus 4. Multiply them, you do get 24, and add them, you do get 10. All right, great. So that's a review of what we had done in the past. Now, to save a little bit of time, because I know I ran out of time on the last video, or almost did. I gave the answer right at the last second. I have already predetermined all of the answers up here, so you can just check to see how you've done. All of these, notice that all of these problems all have a leading coefficient of 1. There's no problem in here that has a leading coefficient of anything else. A couple things I want to point out. Remember, like I said on the warm-up just a second ago, if the C term is negative, then that tells you that they have to be one of each. The two factors have to be one positive, one negative. If the C term is positive, then that tells you either both factors are positive or both factors are negative, or obviously the other choice is it's not factorable. Now, I didn't really go into what does that mean when it's not factorable. That means if you take these pieces, there is no way. If you're taking area model pieces, like algebra tiles, you take one flat, 8 longs, and 7 units, if it's not factorable, that means there's no way to create a rectangle with those pieces. So when we say not factorable, that means there's, like I just said, there's no way to build a rectangle. There's no possibility of doing so. All right, so now what do we do when the A is greater than 1? So we're going to do something that they call online as garbage method. Now, I'm not sure why they call it that, but what you're going to do is you're going to multiply A times C. 3 times negative 5, I'm going to write that to the side, and that's negative 15. Now, the next thing I like to do is I like to list all the factors of that number. Keep in mind, I understand that this is a negative 15. So that tells us that one of the factors has to be negative and one of them has to be positive. But for the sake of doing so, right now, I'm just going to list all the factors as if this were positive. Now, which one of these combinations is going to add up to negative 2? Keep in mind, once again, one of the two factors has to be a negative, and it's this one. So it's 3 and 5, because 5 is 2 bigger than 3. So what we're going to do is we're going to split the B term. We're going to split negative 2 into 3p minus 5p. Because 3p minus 5p is negative 2p. So technically, I've just changed this into a new expression, but they are equal. They are the exact same thing. Let's bring down the negative 5, the minus 5 at the end, and let's bring down the 3p squared that we didn't do anything with. Remember, once again, 3p minus 5p is negative 2p. So I have not changed the value of the original statement. So it's still standard form, although I've split it up into how many longs are on each side of the area model. Now I'm going to split this up into a length and width, kind of like what I just said. And I'm going to factor out the GCF on both sides. This side, both of these terms both can be divided by 3, and they both have at least 1p. So this divided by this is p, this divided by this is 1. All right, do the same thing over here. So negative 5, these can both be divided by negative 5. This divided by this is p. This divided by this is 1. Notice what happened now. Both parentheses have the exact same thing inside of them. That's exactly what's going to happen every single time. So what you're going to do is take the two outsides and combine them together and take what's on the inside of them, and that is the other factor. So I'm going to combine these two together. So that's one factor, 3p minus 5. And then the other factor is whatever was in both parentheses, and that is the answer. This times this is this. All right, let's try that again. So 2 times negative 9 is negative 18. Write out all the factors of 18. So we got 1 times 18, and we've got 2 times 9, 3 times 6. I'm going to pick which one of these. Keep in mind it's negative, so that means one of the two factors has to be a negative. It's this one. So it's going to be positive 6n minus 3n. And then I'm just going to bring down the last term and bring down the first term. Now, isn't 6 minus 3 positive 3? Yes, it is. So I have not changed the value any. So I'm going to split up into length and width, like I said before, factor out the GCF on both sides. Both of these terms can both be divided by 2, and they both have at least one n involved. This divided by this is here. This divided by this is 3. Do the same thing over here. They can both be divided by negative 3, and that leaves you this divided by this is n. This divided by this is 3. So notice what happened again. So the outsides are going to get combined together, and the insides are exactly the same. If you get different things on the inside of both parentheses, that means you messed up, and it is not correct. So 2n minus 3 gets combined, and then the other one is n plus 3. All right, question number 3. 3 times 4 is 12. So it's either going to be 1 times 12 or 2 times 6 or 3 times 4. And it looks like it's going to be 2 negatives because it had to be equal to a negative here. So it's negative 2n minus 6 more n. And that does equal negative 8n. I can bring down the right side and the left side. All right, split the problem in half. Both these can both be divided by n. So this divided by that is 3n, and this divided by n is minus 2. Both of these can be divided by 2. Actually, there's another rule here. If the first term is negative, you have to factor out that negative. So this divided by negative 2 is 3n, and this divided by negative 2 is minus 2. So once again, insides are the same. So n minus 2 times 3n minus 2. There's your answer. This times this is this. All right, next one. 5 times 12 is 60. Now, factors of 60. 15 and 4 is the combination. Now, I'm not going to go through all the factors of 60. So it's going to be 15n plus 4n. And I know that because 15 times 4 is 60, and 15 plus 4 is 19. So that is the split. If you use the wrong split, it will not work. Split it. Factor out the GCF, which is 5n. Leaves you with n plus 3 on the inside. Over here, they can both be divided by 4 with n plus 3 on the inside. So the answer is 5n plus 4, because those were the two outside numbers that got factored out, and the insides are the same, and that's the other factor to the answer. 5n plus 4 times n plus 3, and that rectangle would make those pieces. Now, to save a little bit of time, because I learned my mistake, I've already done the next 4 questions. So you can pause it right here, take a look at these, check your work. I'm going to go to the answers. To the homework now. All right, so the first 3 questions look like a review of yesterday, and the bottom 3 questions look like new questions. So what 2 numbers give you negative 40 but also add up to negative 3? So I'm asking myself, well, hey, that looks like one number does have to be a negative, one has to be positive, and I believe that's going to be negative 8, x minus 8, and x plus 5. That is factorable. Multiply those 2 numbers, you get negative 40. Add them, you get negative 3. Check, check. 48. Think about what gives you 48. 12 times 4. Okay, that's going to give you 16, though, so that's not it. Let's see. 10, 8, 6 times 8. Yep, that's it. X plus 6 and x plus 8. Multiply them, you do get 48, and add them together, you do get 14. Check. All right, this one is a binomial. but it's what we call differences of squares. It's an x minus 5 times x plus 5. Now you might be wondering, well, why wasn't there a b term in the middle? Because it's difference of. Minus 5 red longs and 5 green longs are going to cancel each other out, making no b term in the middle. This only works if this and this are perfect squares, and it has to be minus, because a negative times a positive will always have to be a negative. If this was x squared plus 25, that would not be factorable. All right, now to the new stuff. 2 times 12 is 24. Now, all the possibilities of 24. 2 times 12, we got 6 times 4. We do know they have to both be positive or both be negative because it is a positive number. 12 times 2 is not it, and they both have to be negative because that's to add up to negative 11. 6 times 4 isn't it. 8 times 3 is the split, so it's negative 8x minus 3 more x's. Bring down the plus 12 and bring down the 2x squared. Split it in half. Factor out the GCF on both sides. That leaves me with x minus 4 on the inside. Factor out, remember, if the first term is negative, you have to factor out the negative, so that leaves you with x minus 4 on the inside. So the answer is 2x minus 3 times x minus 4. All right, question number 9. I'm going to change colors so you don't get distracted by what's what problem. 3 times 14. Okay, so 3 times 4 is 12. Carry the 1. 3, 42. So I hope I'm going to find this split. Oh, yep, that's it. 7 times 6. So it's got to be a negative 7x plus 6x. Now, how I recognize that so quickly is because due to the fact that the b term was negative 1, that means that the two numbers had to only be 1 apart from each other. So I instinctively looked for numbers that gave you 42, but they had to be very close to each other. They had to be 1 apart. And 7 times 6 are 1 apart. And it had to be a negative 7 because the b term was negative. So the negative has to be the bigger number. Bring down the 14, bring down the 3x squared, split it in half. They can both be divided by x, leaving you with 3x minus 7. Both can be divided by 2, which leaves you with 3x minus 7. So the answer is x plus 2 times 3x minus 7. All right, last one. I am good for time this time, it looks like. I did not say this in the prior questions, but I did always look to see if there's a GCF first. 4, 13, and 3. I asked myself first, before I do anything, is there anything that all three of those numbers can be divided by? Because if I factor that out first, that'll make my problems so much easier. 2, 11, and 12 don't have anything they can all be divided by. No, neither does 3, 1, and 14. Except for 1, but if I divide everything by 1, that doesn't change anything. 4 times 3 is 12. All the factors of 12. So you got 1 times 12, and that is a split, so I'll stop going anymore. It's 1x plus 12x. That adds up to 13. Bring it down. Everything else. Split it in half. Both can be divided by x. Leaves you with 4x plus 1. Both can be divided by 3, which leaves you with 4x plus 1. And then there is the answer. The answer is x plus 3. Put the two outsides together. Times 4x plus 1. All right, great. I think we've hit the final, and I did not go to the very last second. So thanks again for watching. Please give it a like if I helped you learn something about factoring. I'm hoping this is going to be a pretty highly watched video because this can be pretty tough. And definitely subscribe if you haven't done so already because I have basically everything you would ever want to know about algebra. All right, thanks again for watching. Have a great day.